The vast darkness of space hides countless rocks, silently crossing Earth's fragile orbit every second.
Most of them burn harmlessly in the atmosphere, but a few have the power to erase entire civilizations.
6 million years ago, one such object ended the age of the dinosaurs in a single instant. Today, humanity faces the same cosmic danger, with only science as its shield.
This is why protecting Earth from asteroids has become one of NASA's highest priorities.
It is no longer science fiction, but a real mission, shaping the future of mankind. Every radar pulse and telescope scan could be the difference between survival and extinction.
Somewhere in the silence of space, an unseen threat may already be on its way.
NASA does not explore the cosmos only for curiosity, but also for planetary survival. The war for Earth's future may begin millions of kilometers away from the blue planet itself.
From orbit, the Earth looks peaceful, yet danger constantly drifts in from deep space.
NASA classifies near-Earth objects to identify those that could threaten our planet.
Thousands of asteroids pass close to Earth every year, unnoticed by the human eye.
Some of them are large enough to destroy an entire city within seconds.
NASA calls these objects potentially hazardous asteroids. The true danger lies not in their size, but in the unpredictability of their orbits.
Even a tiny change in trajectory can turn a distant rock into a global threat. In 2013, the Chelyabinsk meteor exploded over Russia without any prior warning.
The shockwave injured thousands and shattered the illusion that Earth is safely protected. From that day, planetary defense became more urgent than ever before. NASA began to invest heavily in early detection systems across the globe.
Giant telescopes now scan the skies day and night without rest.
Infrared space telescopes search for dark objects hidden in the glare of the sun.
Every detected object is tracked and its orbit is calculated with extreme precision.
Scientists simulate thousands of years into the future to predict potential impacts. Most objects pass safely, but a few remain under constant observation.
One of the most famous is the asteroid Apophis, once feared to strike Earth.
Years of observation finally proved that Apophis will safely pass by our planet.
The relief reminded scientists how fragile predictive certainty truly is.
Detection alone is not enough if an actual collision course is confirmed. This is where deflection technology becomes the last line of defense.
In 2022, NASA tested humanity's first real asteroid deflection mission called DART.
The spacecraft was sent to collide directly with a small asteroid at high speed.
On impact, the asteroid's orbit shifted measurably for the first time in history.
The success proved that humans can alter the destiny of a celestial body.
It marked the birth of true planetary defense capability.
After the DART success, NASA shifts its focus from experiment to real planetary defense strategy.
Engineers analyzed the debris cloud to understand how much momentum was transferred.
Data from space telescopes confirms that the asteroid's orbit has been permanently altered. The experiment proves that even small spacecraft can change the fate of massive objects.
World space agencies begin to coordinate under NASA's planetary defense leadership.
The concept of global asteroid defense becomes a shared human responsibility.
New simulations now include coordinated launches from multiple planets and stations.
The goal is to intercept dangerous asteroids years before they approach Earth.
Time is the most powerful weapon in planetary defense.
The earlier a threat is detected, the less force is required to deflect it.
This is why NASA invests billions into next-generation detection telescopes.
The NEO Surveyor mission is designed to find hidden asteroids in infrared light.
Unlike ground telescopes, it can see objects approaching from the direction of the sun.
This fills the most dangerous blind spot in Earth's defense system.
Every newly detected object is instantly shared with global monitoring centers.
Supercomputers calculate countless future scenarios within minutes.
Each scenario estimates impact, probability, energy output, and global damage.
Even a 1% probability is treated as a planetary emergency.
Scientists know that Earth's gravity can slowly pull an asteroid onto a collision path.
This invisible process can take decades without being noticed.
A harmless rock today can become a nightmare tomorrow.
This is Fulton Eva 2 for the emergency on front, turn is right there.
This uncertainty drives NASA-L's constant vigilance.
Detection is only the first stage of a much larger survival system.
If an object is confirmed on a collision course that the world enters a countdown phase. Political leaders are informed through secure emergency communication channels. Military and space agencies begin coordinated response planning.
Every hour of delay dramatically increases the required deflection force.
Scientists prefer gentle nudges over violent destruction whenever possible. The gravity tractor method uses a spacecraft to slowly pull an asteroid off course. This method takes years, but minimizes fragmentation risk. Fragmentation could turn one threat into thousands of deadly projectiles.
That outcome would be impossible to control.
As a last resort, nuclear deflection remains an option only under extreme conditions. A nuclear blast would not aim to destroy the asteroid, but to push it aside.
The physics of space make even tiny directional changes enormously powerful. 1 centimeter per second today can mean thousands of kilometers of missed distance years later.
This principle defines all planetary defense strategies.
Humanity now possesses the knowledge to change cosmic trajectories.
What remains is the will to act.
in time.
Every defense plan ultimately depends on early warning.
The sky is constantly monitored like a cosmic radar screen. Yet not all threats can be predicted with perfect certainty. Some objects emerge from deep space with little warning.
Comets especially can appear as sudden messengers of destruction.
Their high speeds leave little time for response.
In such scenarios, evacuation becomes the only defensive option.
Governments would have to move millions of people within days.
Coastal regions would face deadly tsunamis from ocean impacts.
Continental interiors would suffer shock waves and firestorms.
The atmosphere itself would ignite as the asteroid tears through the sky at hypersonic speed.
A blinding flash brighter than the sun would mark the moment of impact.
The ground would ripple like water under the force of released energy.
Dust and fire would rise into the stratosphere within minutes. Global temperatures could drop as sunlight is blocked by debris. Crops would fail and ecosystems would collapse within months. Civilization itself would face an extinction-level event. This nightmare scenario is exactly what NASA is racing to prevent. Planetary defense exists to ensure that this outcome never becomes reality. Behind every telescope and radar screen stand teams who carry the weight of the world. In mission control, engineers monitor data streams without blinking for hours. Every new signal could announce either safety or catastrophe. The pressure on these scientists rivals that of any battlefield. Yet their weapons are equations and algorithms instead of guns. Their battlefield is the invisible geometry of space. A single miscalculation can change the fate of billions.
This is why simulations are repeated thousands of times before any real mission is approved.
Each rehearsal explores worst-case and best-case scenarios alike. Humanity practices survival long before the real test arrives.
In the future, automated interception systems may respond faster than humans ever could. Artificial intelligence is now being trained to predict asteroid behavior.
Machine learning systems analyze orbital chaos beyond human intuition. These digital sentinels may one day guard Earth non-stop without fatigue.
But even perfect machines still depend on the human decision to act.
Politics and fear can delay action when time is most critical.
History shows that humanity often reacts too late.
Planetary defense forces the world to confront this weakness directly.
The enemy offers no second chance and no negotiations. Space simply follows the laws of physics without mercy.
The universe does not care whether Earth is ready or not.
Every generation lives under the silent watch of the cosmos.
We are the first generation capable of actively defending our planet. This power also carries an enormous moral responsibility.
The lives of future civilizations may depend on the choices made today.
Each launch probe represents a promise to protect unborn generations.
Each calculated orbit is a line drawn between extinction and survival.
The struggle for Earth is fought years in advance in the silent reaches of space.
No sirens sound when a dangerous asteroid is first discovered.
Only quiet calculations decide the destiny of the world. In this silence, NASA stands as the unseen shield of humanity.
Deep space warnings detect a newly calculated object with a narrow margin of impact probability.
The projected trajectory crosses Earth's orbit with terrifying precision.
Global Defense Protocol is activated within minutes of confirmation. Engineers rush toward the final decision that could save or doom the planet. The room falls silent as the final deflection window is identified. A kinetic interceptor mission is approved without hesitation.
The launch vehicle stands ready as dawn breaks over the coastline.
Flames erupt beneath the rocket as planetary defense leaves Earth's surface. Millions of people unknowingly look up at the sky beneath its rising fire.
The interceptor streaks across orbit, guided only by mathematics and faith. Hours stretch into days as correction burns refine its deadly accuracy. The asteroid grows from a pixel into a massive rotating mountain of stone. Onboard sensors begin transmitting real-time collision parameters. Mission Control counts the final seconds in absolute silence. The interceptor collides at cosmic speed, releasing all its kinetic force. A brilliant flash marks the moment Earth's fate is rewritten.
Dust and fragments scatter harmlessly across deep space. The asteroid's trajectory shifts by only a fraction of a degree.
That tiny change grows into thousands of kilometers of safe miss distance.
Updated calculations confirm the object will now pass safely beyond Earth.
Cheers erupt across Mission Control as years of preparation succeed in silence. No cities burn, and no oceans rise on that day.
Humanity continues its routine, unaware of how close extinction once came.
The greatest victories of planetary defense leave no visible monument.
Only continued survival stands as proof of success.
The asteroid vanishes slowly into darkness, carrying no headlines behind it.
Earth remains suspended in fragile calm beneath the stars.
The battle for Earth ends not with explosions, but with quiet precision. This is the hidden war humanity fights beyond the blue sky.
NASA does not only explore space, but stands guard against it.
Civilization survives today because calculations outran catastrophe.
The universe continues to test humanity with indifferent patience.
Every passing year without impact is itself a silent victory.
The night sky remains beautiful precisely because it is also dangerous. Humanity now looks back at the stars, not only with wonder, but with preparedness.
The most important exploration is no longer outward, but defensive.
Knowledge becomes the first shield, and technology the second. The future of Earth will be defended by those who listen to the silent language of space. In the endless darkness above, Guardians continue to watch without rest. Tonight, the Earth sleeps safely beneath that invisible shield. And tomorrow, the watch will begin again without applause. Because in planetary defense, success is measured only by continued existence. The universe will never stop testing life on Earth. But for the first time in history, Earth is no longer defenseless. Deep space warnings detect a newly calculated object with a narrow margin of impact probability.
The projected trajectory crosses Earth's orbit with terrifying precision.
Global defense protocol is activated within minutes of confirmation. Engineers rush toward the final decision that could save or doom the planet.
Data screens glow with impossible numbers, measuring mass velocity and impact energy. Room falls silent as the final deflection window is identified.
Trishore. A kinetic interceptor mission is approved without hesitation. The launch vehicle stands ready as dawn breaks over the coastline. Flames erupt beneath the rocket as planetary defense leaves Earth's surface. Millions of people unknowingly look up at the sky beneath its rising fire.
The interceptor streaks across orbit, guided only by mathematics and faith.
Hours stretch into days as correction burns refine its deadly accuracy. The asteroid grows from a pixel into a massive, rotating mountain of stone.
Onboard sensors begin transmitting real-time collision parameters. Mission Control counts the final seconds in absolute silence.
The interceptor collides at cosmic speed, releasing all its kinetic force. A brilliant flash marks the moment Earth's fate is rewritten.
Dust and fragments scatter harmlessly across deep space.
The asteroid's trajectory shifts by only a fraction of a degree. That tiny change grows into thousands of kilometers of safe miss distance.
Updated calculations confirm the object will now pass safely beyond Earth.
Cheers erupt across mission control as years of preparation succeed in silence.
No cities burn, and no oceans rise on that day.
Humanity continues its routine, unaware of how close extinction once came.
The greatest victories of planetary defense leave no visible monument.
Only continued survival stands as proof of success.
The asteroid vanishes slowly into darkness, carrying no headlines behind it. Earth remains suspended in fragile calm beneath the stars.